Lesson 2.2, the limits of a function. Our objective is to understand and calculate limits graphically, and to do so from one side versus two-sided limits, right? And we should be able to find vertical asymptotes. So first, what is a limit? It's kind of like having a limit is like finding the intended height or the y value of a function as x approaches a some value, let's say a, right? So in our case, let's say if a is over here and maybe a function looks like that. Oops. Maybe a function looks like this, and maybe that is L, right? So as a value is approaching this way, my y value is approaching this way, which means that graphically it's going this way, isn't it? Yeah, so it goes this way, and it's approaching this way, or from the left, this way, then it will go up this way, and let's go this way, okay? Yeah, so yeah, that's basically what it is. Let's get to this, but before we do that, let's take a look at this, guys. We are saying that as x approaches a, the limit of the function is L. L here is a real number, so this is a real number, and we denote that with stylized letter R. And then, yeah, that's it, right? So that's the output. We're looking for the y coordinate, basically, because the output of the output of the f of x is a real number. And the right-hand limit will be written this way. Let me scoot that in a little bit. It's a limit as x approaches a from the positive side, that's the right side, we get f of x. So what that means is that x is approaching from right side. Hence, we have a positive sign. Okay, so what we may have is something that's approaching from the left, right? And then what we would do is put a negative sign, and we would say that it's approaching from the left side. Okay, all right, guys. So when we state this over here, guys, okay, limit of f of x as x approaches a, and then it is equal to a value L. That is true if and only if both of these statements are true, right? If this is the same as this, let me zoom that in just a little bit, is equal to, and coming from the left, from the right and the left, is both equal to the same value, L. So whenever you see this, guys, without any plus or minus sign, it means that the value is the same L, whether it comes from the right-hand side or the left-hand side. All right. So what you should do is take a moment to try this out on your own. In a regular classroom, I would have you guys maybe work on this as a group. And so you should pause the video. Okay, I'm gonna just rattle out the answer as I'm reading through this, right? So we have this one over here. Let me put that in a color. Let's go with blue. All these values are going to a 0, so I'm just going to draw a line with the blue line right there. Oops, that's not really showing. So let's go with highlighter. Let's make it a little thicker. Oh, that's thick enough, actually. There you go. So when I see that, what we have here is that's where x is equal to 0, right? Coming from the left, because you can see it is approaching -1, right? And then coming from the right-hand side, what we have is this over here. It is approaching 1. And then because they are different, it does not exist, because the limit from the left, which is equal to -1, that is not equal to the limit as is coming from the positive side, which is equal to 1. And f of 0 at that point is 1. Okay. Let's try with something else. Let's go with green this time. And all the values over there are approaching 1, which is like right here. And then that is x is equal to 1. Coming from the left, as you could see, it's going towards 0. Coming from the right, it is approaching 2. And then because they are, what is it? The two values from the left and the right is different, is dne, and just get in the habit of because the limit as x goes from the right of the f of x is different from the limit of coming from the left. Okay, you don't really have to write down the, forgot to put equal sign there. Write it down because we just saw you do that, and the f of 1 is equal to 0. In both cases, we see that the function of the value was equal to one of the values. Is that a trend? We'll see. All right, let's move on to maybe navy blue this time, and highlighting the navy blue as well. And it's approaching 2, so we are here. So the x is equal to 2. As you could see, coming from the left, it is approaching 2. Coming from the right, it is approaching 2. Okay, so from the left and the right, as you could see, this way and this way, it's approaching the same value. It's like two fingers are touching each other, right? And therefore, the value, oopsie, it must be equal to 2. But what is f of 2? That is 3. It appears that the value of the function at that point, which the limit is approaching, has nothing to do with the value of the limit. It appears that way, right? Let's move on with a different color at this point, magenta, and that's approaching 3, like right here. And we have x is equal to 3 down here. And I think that's intruding upon the space, so let me erase that. Oops, let's make it a little bigger. There you go. Okay. All right, so what is the value coming from the left? It's going down this way, right? Coming from the right, it's going down this way, it looks like. Okay, so therefore it is negative infinity, because they're equal to each other, left and the right. So it's the same. F of 3, we just gonna say dne, because f of 3 is not a limit. Technically speaking, infinity is also dne. It doesn't exist, but it does give you an indication what it is, though. Is it just a abyss of nothingness, or is it approaching a certain value? Is it constantly getting bigger, or is it constantly becoming smaller, as in to the left of the number line, right? So negative infinity versus positive infinity. So it is a very specific kind of does not exist. In this particular case, x equal to 3 is an asymptote. There is no value. So it is not a positive infinity because we're asking what is the y value at that point. So it can't be infinity and it can't be negative infinity. It simply doesn't exist. I hope that makes sense. All right, the last question. Yeah, I think some of you may be confused by this. Yeah, you need to look at this picture, guys, and sort of like imagine where it ends. It looks like it's still increasing. In fact, I drew that with a log, right? Log function. So yes, it is in positive infinity. Yeah, so unless you see a pattern in which it sort of flattens out for a while like this, right? You cannot say that it's approaching a specific value. If it does and the value is L, you would actually put L here, but that's not the case, right? Because the actual one is actually increasing. All right, guys. Continue on. Let's take a look at this value. So limits involving infinity. Now, we're looking at this right here. It's 1 over x squared. That looks a little familiar, doesn't it? That looks somewhat similar to 1 over x. And when we graph that, it looks like this, right? If you square something, all these y negative values become positive. It flips up this way. But when you square it, numbers that are bigger than 1 gets bigger. the numbers that are less than 1 gets even smaller. So if, let's say, this is the 1, this gets higher, but this gets shorter, right? So anyways, so it doesn't have to be an exact picture, but I like to get a small sense. So if it's 1, plug it in. 1 over 1 squared is 1. If you put it in half, that becomes reciprocal of that is 2. Square that, you get 4. 1, 2, 3, 4 right here, and this it's a mirror image, right? If you go 2 over here, it would have been half. You square it, becomes a fourth, right? So you could just use a few points to help you. Oops, it's drawing on an iPad is not the easiest thing in the world. It's kind of slippery. There you go. So just give it an indication of what it is, and that's what the picture looks like, right? So in this particular case, they're asking you, evaluate the limit as x approaches 0. So now you have to be concerned with what's happening, right? Right, so the limit as x approaches 0 from the positive side is positive infinity, and limit x approaches from the left-hand side of 1 over x squared is negative infinity. Therefore, we could say that the limit of x approaches 0 of 1 over x squared is indeed positive infinity. So technically, infinity isn't fixed number. So this limit is technically, as I mentioned earlier, does not exist. But technically, infinity is equivalent to does not exist, right? However, positive infinity gives you two things. Gives it gives you a direction. Is it positive or is it negative, right? That's important. And B, it's telling you the value is a growing value, right? It's not a complete abyss. But then again, when you have a function that's butted against an asymptote, you're either forced to go positive infinity or negative infinity, unless the author of that particular question decides to put a hole in there. For what I mean by that is, like, let's say you have an asymptote right there, and maybe you put a hole. An example looks like this, right? In that particular case, it would have a limit. That's the only exception that I could see to an asymptote. Now, in this particular picture, we are very familiar with this graph, right? It looks like something like this, right? Make sure it doesn't curl away. That's 1, 1, negative 1, negative 1, right? All right, so graphing helps. That's why I always will ask you to graph something. It always makes things a little easier, right? We could say that the limit as x approaches 0 of 1 over x is dne. It does not exist because the reasons are the limit. Oopsie, that was pretty bad handwriting. Sorry about that. Limit as x approaches 0 from the positive side of 1 over x is positive infinity, which is different from the limit as x approaches 0 from the negative side of 1 over x, which is negative infinity. Okay? All right, guys. Let's slide forward. And this next particular problem, what I want you to do is just take a look and see how you would do this. Okay. So you had a moment to think about this, right? Now, when you see this particular expression, we know that there's a vertical asymptote at x equal to 2. So when you do the graphing, this is nothing more than this graph right here, shifted to the right by 2, right? 2. So it looks kind of like this. Now, for me to graph this will be a pretty huge task, right? So what you want to do is you could actually do this something akin to sign analysis, right? We know that looking at this functions, they're the same, so we could actually use the same graph, right? I made a mistake. This should be 0. Okay, my apologies, guys. So let's just graph it out, see what happens, right? We could just estimate the graph, okay? So we know that the zeros of this graph is just 1 and undefined values at x equal to 0 or -2. Now, let me make that a little bigger and let's just draw this out. You should, if you're copying this, guys, you should draw it over here because I'm going to actually move it to that area. Let's go the light blue here. So if you draw this and we got 0, we got 1, we got -2. Now this value is a 0 and this is undefined. So this is asymptote. Now what you could do is actually plug in some values. Okay, so this is a 0, this is undefined. So what happens when you plug in a value in this region? Pick a number, any number. Let's say 2. Plug it in over here, what do you get? Positive, and a positive. So I'm gonna go in that order, guys. I'm gonna just go this one in this manner. Okay, so that's a positive. If I decide to plug in a value here, let's say half, that's gonna be negative, positive. Sorry, positive, right? So that's negative, positive. So the entire value here is positive, the values are negative, and then when you go in between these two values, let's choose -1. That's going to be negative, that's still positive. -1 here is what? Positive. Oh, it didn't change. But then again, guys, we are transitioning through 0 here, right? When you go through 0, that's been squared, the value doesn't change, right? I hope you remember that from Algebra 2 and Pre-Calculus class. And then let's pick a value in this region. Let's pick -3, let's say. When you put -3, that's a negative, that's a positive, that's negative. So it's negative, positive, which makes it positive. Another thing that we should consider is that the denominator is x cubed. So that's like an x cubed, and the numerator is x. That's similar to 1 over x squared. So what happens when you do that, guys? Right? 1 over x squared, as x goes to infinity, it's going to go towards a 0. So I know that it goes towards a 0. And also, it's positive. When you go to the negative infinity, it also goes to, make a little darker ones. Like this, right? It goes like this. All right? Now let's go back. This is 0. So this is positive. This is negative. So and because it's infinite asymptote, it must be doing something like this, right? So I'm not even plugging the values. I'm just giving you general shape more than anything else. And because everything is negative over here, right? It is not even 0. It must be doing something like this. Exact shape, I don't know. But what's important is going down, and this is going down. At some point, it will come around. Because everything is positive and to the left hand side is approaching 0, and this must be going like this. So I have a general shape of this without even plugging in anything. Okay. Now, so that's what I did. Let me shift to put it right there. Now, what you can do is try to plug in. The alternate way of doing this is try to plug in a number that is very, very, very close to 0. For example, you could get away with plugging in 0.01 and then -0.01. And if you get a different sign, you know that it doesn't have limits, right? But I think your ability to graph this is important. It's an important skill set, and it's a good review from skills that you learned last year. So looking at this, guys, I'm just going to refer to this as f of x. Okay. So we know that the limit as x approaches 0 from the positive side is going to -infinity, right? From the left hand side is -infinity. We know that f of x is equal to limit as x goes to from the left hand side f of x is equal to 0. Therefore, the limit as for the final statement, I would actually prefer to write down the original question is indeed -infinity, I meant to say. All right, there you go. All right, on the right-hand side, what we have is what is happening as it is approaching -2, like over here. Clearly, on one side is positive infinity and negative infinity, and you know that this is DNE, does not exist, and you always give the reason, because the limit as x is 2, and denote that what you want to call this. This time I'm going to call it g of x, because I call something else. Actually, you know what? That's silly, because the same function, I should just stay with f of x. So f of x is positive infinity, and that is different from the limit as x goes to -2. That's from the negative side. From the positive side of that, it goes to negative infinity. Okay, guys? All right. Now, in our case, the line x of a is called a vertical asymptote. In our case, the a consists of 0 and -2, right? Of y is equal to f of x if at least one of the following is true, right? That number one, that the limit as x approaches a from the negative side of f of x is either positive or negative infinity, or second possibility is the limit as x approaches a from the positive side of the function is either positive or negative infinity. Okay, I got too excited with the, let me make that a little smaller. Okay, there you go. Or we have a limit as x approaches a from either side is the same. F of x is plus or minus infinity, or possibly even does not exist. Okay. All right, guys. Well, me actually stating this one statement includes all this, because if limit over here is DNE, it implies that these two are opposites. If it's positive infinity, then they're both positive infinity. If this is negative infinity, then they're both negative infinity, right? If you think about it, this one statement implies these two already, but I thought that I would write out everything anyways, okay? All right, guys, we got one more page to go, right? This particular one talks about the different kinds of scenarios in which the limit doesn't exist, right? And it's kind of similar to, well, not similar, but it's somewhat related to the discontinuity, right? We saw this in the past last year. There's a jump discontinuity. Well, anyways, this is true when the value is different from left to right. There's a specific value, right? In this case, this is equal to what, 3.5-ish, and this is equal to 2. So in this case, the limit as x approaches, that was 1, right, of f of x does not exist. Okay. In this particular case, it's the same thing. Left and the right is different, but in this particular case, it's unbounded, right? Meaning it's going to the infinities on either side, right? Whether it be positive or negative. So in this particular case, the limit as the x approaches 0 of the function is DNE. This one is a little tricky, and I may have to explain further in class, but here is quickly what's going on. So we know that the y equal to sine of x, guys, is like this. It goes up and down forever, right? But when you have 1 over x, as x goes towards the infinity, 1 over, as x goes to the infinity, 1 over x goes to 0. So it's kind of like all this, as it goes to here, is being crammed into smaller and smaller space. So it's not equally spaced out anymore because it's 1 over x. So as it's going towards here, it's going up and down feverishly between positive and -1, and never stops. We could never get there, right? Because x goes to infinity forever, which means that 1 over x goes towards 0 forever and never getting there. So it gets tighter and tighter and tighter. So it goes up and down to positive to negative 1. Yeah, if you kind of think about it, it's a little freakish, right? All right. Well, or fantastic, that is, right? So therefore, basically, the function is oscillating. Therefore, the function doesn't exist. As in this particular case, the limit as x goes to 0, the function doesn't exist, basically due to oscillation. Okay. All right, guys. Yeah, for this one, you could use a graphing calculator, plug in the value like maybe 0.001 or something like that.
It's 9 o'clock.
And you should be getting something like this is equal to 0.587, or maybe you, depending what you put in, it might have been 0.588. For something like this, unless I specify what the value is, I'm not gonna be too much of a stickler for this, right? So the x in this case, use very small value. For example, x could be 0.01 or even smaller than that. But beyond that, I don't think it makes much of a difference. Okay. Now we have the next three example. The point of this example is to tell you that graphical knowledge of the function is very important. Okay. So let's draw out. Looks like we have tangent and we've got ln. So we have to know what that looks like, right? So let me just draw it in here. I'm going to move it to the bottom. Just keep that in mind. Y is equal to tangent of x. That is essentially between pi over 2 to negative pi over 2. And that's asymptote here and here. At pi over 4, it's 1. At negative pi over 2, it's negative 1. And it's going to look something like this. And that thing repeats itself like this, right? Okay. And then y is ln of x. It's like any of the log with a base e. Looks like this, guys. So there is that asymptote is here. And this thing is increasing forever slowly, but it's going to infinity in y value. Okay. So let's keep that in mind. And as we're going to put this like right here, we're going to use that as a reference. Now, in this particular case, it's asking for pi over 2 from the left-hand side. So we're looking at this here, guys, come from the left-hand side. So it means that it is positive infinity. So if you draw a graph, for me, that is sufficient work. Okay? There's no... So when you're familiar with this common graphs, there's no need for you to use a calculator. So this kind of question will be a non-calculator question. And let's look at this question right here, guys. Let's put this over here. What is happening as the value is approaching 0 from the positive side? It's going to negative infinity. Now, what this one is saying over here, they combine the two functions with plus sign. So we could separate them. So it's a limit of x goes to positive infinity of tangent of x. And that in this particular case, it is doing the same thing with ln of x. Now, we know that this is what? Negative infinity, right? Because we've already done it. So adding the negative infinity. And we have, in this case, from the positive side. Well, when you approach from that, oops, to the 0, that's 0, isn't it? So 0 plus anything is itself. Therefore, this must be negative infinity. All right, guys, that is 2.2. We usually give lesson 2.2 and 2.3 at the same time. So if that's the case, make sure you go ahead and watch 2.3. Thank you, guys.